that we're looking at is over 103 million points. And so those are just a few of the questions that people ask us. So I'm going to zoom into an area just to give you a little bit of a look how this LiDAR looks over the image. Some people do like to see that themselves, and it just seems to be visually appealing in a different way. But I'm going to turn off this image for now. Right now you can see that we're viewing by elevation, but we can also view by classification. Browns County, I think they used their LiDAR mainly for hydrological modeling, so really all they needed was their water and their ground classified. But you can classify your vegetation and your buildings, kind of like what I did right here, and those are a couple of different viewing options that you have. But you can also view your points not only by your points, but also a triangular irregular network, which is a tin. This will give you a feel of a 3D surface model. This tool is mainly for visualization purposes. Depending on what you're analyzing or trying to interpret, the tin model is quite useful. So say you want to see a good representation of elevation. The tin model, as you can see, will show you visually the differences in elevation. So you can see the bigger or the more taller areas are in red, the lower ones are in blue and green, but it's not a very elevated area. This part of Wisconsin is pretty flat, but you can kind of see the idea. Intensity is similar to an orthophoto, and it can be a big advantage for those of you who are in a hydrological setting or maybe even emergency management because of its usefulness for heads-up digitizing. So objects such as your metal roofs will have stronger return than asphalt on your roads. It's not exactly an infrared image, but it can help you interpret and classify those points without having to create a surface model. And another useful way that we have found that people like to use is that they can view the intensity over their classification in using the LP360 tools. So this is very useful. You can see the roads in here, and if you wanted to get those out of there, oops, you could probably do that. I did want to move on and show you what I was talking about earlier with the multiple returns. Magenta that you see here represents the single returns, and the more colorful areas like the green and the blue represent multiple returns that I had mentioned earlier. So you could guess that the backscatter of this is probably your vegetation and probably some buildings. Typically the first returns can be used to create digital surface models, so everything like your surface, like your trees and your buildings. Your intermediate returns can be used for separating vegetation from other parts, and final returns are used for bare ground surface models. You can also, in LP360 at least, view your flight lines. People find this to be useful during QA/QC processes. You can also see if your points overlap and maybe see the density in those areas. So just to show you what those look like. Okay, so like I said earlier, you can view by a tin, you can view by points, but you can also choose to view by a wireframe in LP360. And I really only wanted to show you this just so you can see how your points are interconnecting in your tin model. A lot of people like to use this tool just so that mainly for hydrological modeling, which I'm sure Paige is going to be demonstrating for you in just a little while. But that's the main reason why I wanted to show you this area. And we've come to find that a lot of customers like to use LP360 for contours, and I wanted to show you what the contours look like in here. You can kind of see them in this area. Like I said, this isn't a very elevated part of Wisconsin, but I did want to show you this with the true orthophoto. Some people would like to see those contours. They would like to use those contours that are derived from the LiDAR to show over their images. So we did find this to be quite useful for many people.